Here, I'll review evaluating the polarity of polyatomic molecules with 3 or more atoms. To do this, we need to use the Vesper model to predict the shape of the molecule. With 3 or more atoms, the molecules will have 2 or more bonds. So we need to identify the polarity of the individual bonds in the molecule. To evaluate molecular dipoles, treat dipoles, if any, like vectors, and use symmetry to help your evaluation. For example, if equal dipoles are pointing directly away from each other, or equally pointing away from a central atom, then there is no net dipole moment, and the molecule is nonpolar. There is a symmetric distribution of dipole moments. The same is true if equal dipoles are pointing equally toward a central atom. However, sometimes the dipoles do not cancel because of sharper bond angles due to shapes or differences in dipole moments within a molecule. For example, some polar covalent bonds contain larger dipoles within a molecule than other bonds. In these cases, a larger molecular dipole can be drawn to sum the individual dipoles. In these cases, there is a net dipole moment and the molecule is polar. There is an asymmetric distribution of the dipoles.